It's something I'm really passionate about. And also, I honestly think that, oh, and I also forgot that I did not share my screen. So let me do that right now. All right. If I screen share, right. Yeah. And so I'm really passionate about it, but also technology is something that society is heavily influenced by today. We are we're very used to technology, and we see it even in the places that we don't really know. So for example, when you take, I guess, the marketplace, for example, a lot of companies use the data that they gather from what customers buy to figure out where to place items to maximize profit. This is all done through computer science. So that's why you'll most likely always find things like milk and eggs, which are very popular items that people buy at the end of the store. It's so that you'll look at and be tempted to buy more products while you're on your way to get milk or eggs or something else. Similarly, data analysis is being used to figure out, I guess, when items should go on sale and whatnot. Of course, other fields also use computer science. So in the medical field, robotic arms are being developed to be used for surgery. We also see things like Watson Health experimenting with using computers to provide patient care. In such ways, you see technology being integrated everywhere, even learning. So without Zoom or the internet, this whole webinar wouldn't be possible. But computer science, I think, may seem a little intimidating in the beginning. It certainly was for me, because you hear all the buzzwords like artificial intelligence or machine learning or quantum computing, and these seem like such complicated concepts that aren't really easily sort of accessible for us. But this isn't really necessarily true. And so today, I want to sort of introduce you guys to the basics of programming and show you how programming isn't as difficult or complex as it may seem like at the beginning. So to do that, I'm going to be showing you a couple of different applications, programs that I've written, and do that using different languages so that you can get a feel for, I guess, the different areas of programming. All right, well, to start off, let's briefly go over what programming is. Oops, I somehow drew something. Hopefully these will go away. But, all right, it goes away normally. All right, to start off, so what is programming? Well, you can think of programming simply as a set of instructions that we tell the computer, we write down and tell the computer so that we can get the computer to do what we want. All right. But what's really important to note here is that the computer is surprisingly very dumb or stupid, because it doesn't really have any intuition and can only do exactly as we tell it to do, what we tell it to do. So what's important in programming is that we give it really clear and complete instructions without taking any assumptions. With all that being said, let's dive into some coding. I should note that if you have any questions throughout the hour, definitely feel free to comment in the chat, and I will try to check that regularly and answer questions for you guys. But if you also honestly see me just going away and not answering your questions, I think for me, feel free to just unmute yourself and ask directly. I'll also be asking questions to you guys, so stay tuned, and if you think you know the answer, unmute yourself again and answer. All right? Okay, so getting back to actual coding, first tool I want to introduce you guys to is Python. I think you guys saw it yesterday doing some computer vision work, but it's a programming language that I think is very intuitive and beginner friendly. So, and in Python, there's a lot of different packages that you can use. And when I refer to packages, it basically just means that someone else already wrote a bunch of code on a specific topic, whether that might be math or doing some randomization, and made it public so that others can refer to it and program more easily, rather than having to go through and write out all of the instructions again for that specific theme or topic. Specifically in Python, I'm going to be using the turtle package, which lets us draw, and it's called turtle because, as you can see in the picture here, the pointer that's used to draw is shaped like a turtle. So, all right, so I'll first show you guys this in action. And the way I'm going to go about doing that is using terminal. And this is where I can basically ask the computer to do what I want. In this case, I'm going to ask the computer to run turtle demo.py, and this turtle demo.py has code instructions that I want the computer to run, and I'm telling it run it using Python. So this is going to be very simple. So what you see here is that a window popped up, and the computer drew 2 lines for us. If we see this in the code, what we see is, oh, not here, here. All right, so ignore the top part for now. Look at just lines 9 to 11. I'm telling the computer, hey, move the pointer forward 100 pixels, make the pointer turn right 60 degrees, and then make the pointer go forward again 100 degrees, which is exactly what we saw in the program, right? It drew 2 lines, which were 60 degrees or 120 degrees apart. So diving more deeply into the other aspects of the code, we see the first line, import turtle, and I'm basically telling the computer, hey, I want to use the turtle package, which has a bunch of other code. Then I want to initialize a window. I say, hey, create a window that, create a screen that I can draw on. Then I tell it, hey, I also want to create a pointer with which I want to draw with, and I want the pointer shape to be a shape like a turtle. Then, even though the program already ran a little bit fast, I want this is actually the slower speed, so I'm setting it to 10 rather than making it go incredibly a lot faster. Then we have the code for making it go forward and turning and going forward again. And this last line right here is saying, hey, I don't want you to exit the window right away. I want you to wait until I click on the window to close it, because otherwise the program would have finished running and the window would have gone away, and we wouldn't really have had time to look at it more in detail, right? So looking at this, it's pretty simple. So knowing that, how can we build a square? Any ideas? You guys can unmute yourself and just shout out any ideas. Doesn't have to be right or wrong.
Also, feel free to send any of our staff members, instructions for making the square if you absolutely need to. But we really do suggest that if you have something to say, go ahead and say it.
Yeah, for sure.
Move forward 100 pixels. Turn right 90 degrees. Move forward 100 pixels and repeat for another 2 more times.
Yeah, that sounds amazing. All right, so let's try and write out what you just said. So I'm going to comment it out so that the program doesn't run this anymore. Rather, I'm going to do exactly what you guys just told me. So I'm saying move forward 100 pixels, and then I want you to turn right 90 degrees. Then I want you to move forward again 100 pixels, and then I want you to turn right 90 degrees again and repeat this twice. So let me just copy that down here. All right, and should we see if this works? In order to do that, we just go back here and then run this program again. And as we want it to, it draws out this whole square. So perfect, we have a square going. But if we look back at the code, this is pretty repetitive, right? Just as you said, repeat twice. You can also think of it as repeating these 2 lines of code 4 times, because, you know, you see going forward and turning right, going forward and turning right, forward and right, forward and right. So another thing that I think when you're programming, you want to make sure is getting rid of sort of the redundant, repetitive lines of code. Because think about if we wanted to make, I don't know, 100 squares. I don't know why, but maybe you do. Then we already are at 800 lines of code, right? And that seems a little excessive if we're just trying to draw squares. So something that programmers created is this concept of a for loop. So we say for I in range 4, and let's say this is the body of code, if I can type. All right, so what this does is saying, hey, I want you to repeat from I starting at 0 to I being less than 4, I want you to repeat whatever is inside, so indented inside this code, inside this body of code. And so what we would do here is copy this in so that you have, all right, so I want you to go forward and right 4 times in this loop. And indeed, if we comment this out and run the program again, you'll see that it draws the same square that we want it to. But instead of taking 8 lines, we're able to do it in 3 lines. So we've made it a lot more efficient for the computer, I guess. But you might be wondering, hey, like Hyunji, drawing a square isn't that interesting at all. And I agree with you. So how about, can we build a spiral? It looks a little more complex, but does anyone have any ideas in taking a stab at how you might go about drawing a spiral with Turtle?
I think we loop for short distances, like for 1 pixel or something like that.
Mm-hmm. Yeah, no, definitely you're right. We're going to be utilizing the concept of a for loop again. It's, although, you know, a square and a spiral seems vastly different, if we go back to our code and we go to this turn spiral, ignore whatever is up top, but you see this for loop again, except instead of looping over just 4 times, so making 4 lines, we're looping over it 1,000 times so that we're making 1,000 lines. And you can see here that I mentioned to you how I basically starts at 0 and increments by 1 until you get to whatever number is here. So I starts at 0, so you initially go forward 0 pixels, and then the next time around you go forward 1 pixel, the next time around you go forward 2 pixels, and so on. So if I actually show you guys, oops, I don't want to put off zoom. If I show you guys how Turtle actually draws this out, you'll see Python Turtle spiral. You'll see, oops, the first is really hard to see because it's not really moving a lot of pixels. But you see how it's going around. It's sort of making the square shape. But if you notice that in my code, I was moving forward, I was rotating 98 degrees at a time. So it's just slightly off from a square, allowing us to sort of make a spiral instead of just making the same shape. And it's also moving forward in increasing amounts of length, which is why you sort of have a sort of, I guess, a spiral going. You also notice that this color changes. And you can notice the color change in, if I go back to my code, here where I set the different color, right? I say pointer.color is color. And the way I choose color is from this colors list. This colors list is basically 100 RGB values, and RGB is just basically I need to give it 3 numbers. how much of red, how much of green, and how much of blue we want for a color to have. So we have a list of all of the different colors I want it to use. I'm basically telling it, hey, I want like the 0th element, or I want it to get the first element, or I want it to get the second element, and so on, so that we're changing the colors in that way. You also notice that, usually when you do division, you do like 2 divided by 3, right? And that would give you 0.67 rounded off. But in this case, when we do two forward slashes and then a 3, then it's basically getting the quotient. So you're basically rounding down the number so that you get an integer number. So in this case, 2 divided by 3, this is basically called integer division, would give you 0, because rounding down 0.67 gives you 0. And in that way, I only change the color basically every 10 times. So when I is 0, it gives you the 0th index. If I is 1, 1 divided by 10 in integer gives you 0 again, and so on. So in this way, I change the color every 10 turns or so. All right, so with that, you sort of see how even though drawing a square and drawing a spiral, I would honestly say spirals are cooler. Even though they're vastly different, it sort of utilizes the very, very similar sort of context and syntaxes of code, right? And that's basically what you're going to see in a lot of, I guess, different applications. So let's go into some different concepts, because we've seen how we can use programming to draw. So let's use programming to create a game. In creating a game, I'm going to be showing you one that I made using HTML and JavaScript. So these languages, HTML and JavaScript, CSS as well, are languages that are especially useful when you want to build web applications. So if web applications, and the specific game that I'm going to be showing you is a very simple like ball game. I think it's called Brick Breaker. I'm pretty sure a lot of you have already played it, but for those of you who haven't, let me just go ahead and show it to you. All right, so you basically move around this bar at the bottom and try to get the ball to stay afloat, I guess. And you want to remove all the blocks that are up there. And if you remove all the blocks, you win. And if you basically let the ball drop too many times, then you lose. So it says game over. And this seems very different from, I guess, drawing, whether it be drawing a spiral or some other shape. But if you actually look at it, it has very similar concepts. So let me go to this body of code. And what you'll immediately notice is that, Python didn't have any of this type of information, right? It's because this is what HTML uses. And HTML is a language that's used to sort of specify how we create websites. So in doing this part, and I basically hid some parts, but if I open this part up, you'll see that this context of code is used to set the header of our website game. So I want the title to show as Brick Breaker, which is why when I went to the website, you see the Brick Breaker showing up on our user tab. And then style, as you can see, shows you the different styles for how you want this setup to be on the tab. Hiding that, we come to the actual important part of the code, sort of the body of our code. In the body, we specify, hey, for header 1, we want this. I want to say Brick Breaker, and that's exactly what you see here. Then I want to set a canvas of 480 by 320, so that I'll be for which I'll be able to draw my game on. All right, so moving forward, you see all of these different variables being defined. You can honestly safely ignore them for now, but what we're doing is, hey, I want to use these numbers 10, 75, 8, but it's also very difficult to understand what I'm trying to say if I just give a very random number 10 in the middle of nowhere in my code. So I'm saying, okay, well, paddle height is going to be set to 10, and when I use this variable later on, it's going to be easy for me to understand, and also when other programmers look at my code to understand, because paddle height is pretty intuitive to know, right? It sets the height it's how high my paddle should be. All right, so coming down here, do you guys notice anything different for this for loop from the Python for loop that we saw? I saw a nod. I think that's a good sign. All right, so what's different here is that instead of just saying for I in something, we actually say, well, I is, we'll see in this case, is going to start at 0. And we're going to iterate over this body of code until C is less than, while C is less than brick column count, which I think I set it to 5 above 5, yep. And we're going to iterate over with C increasing by 1 every time. So what this basically does is initialize all of the bricks. So when you go back here, you'll see this game over is going to show up, but you see 1, 2, 3, 4, 5, 6, 7, 8 columns and 5 columns for the 5 rows for the bricks. So once again, you see very similar context of sort of different for loops being used. Another aspect that you'll see is all of these functions. And what these functions do is, let me just open one up, for example. Let's say function draw ball. It's sort of exactly like sort of the forward or right command that you saw, but instead of this turtle package having defined what forward and right does, I actually had to define it manually because no one else wrote that code for me before. And so this draw ball basically just draws a ball, draws a circle of radius, whatever, in the positions X and Y. And what's important to note is that even though I define all of these different types of functions down here, you actually don't see any of them carrying out these functions unless you call it, unless you call the function explicitly. It's sort of like in a recipe, they might tell you how to chop up some carrots or, I don't know, mix all of the vegetables together, but you don't want them doing that until there's a specific line that says, hey, now is the time that you should chop up those carrots that I told you how to do so. All right, and if we look inside this draw function, you see that all of these other functions are also being called, and that's where and how this is being used. Coming down, you also see these if statements. These are very intuitive, I would say. It's conditional statements. So if whatever this condition inside is true, and only then should you do whatever is inside the body of code. Otherwise, it says else if this is not true, but if this other condition is true, you should be carrying out another type of function. In that sense, you see how the sort of code is, we added on to our knowledge of code from just having for loops and setting variables to also learning about how we can set functions and also use if-else conditional statements. All right, moving forward, you can see that this is sort of the general trend that you see for a lot of different programming languages and applications as well. So the next one that I'm going to be showing you is a game using Java. It's a memory scramble game. And if I just show that, I'm also realizing that I don't really have too much time, so I might zoom over this memory scramble game a little bit. If I play the game, it basically lets me choose 2 different cards. These don't match, so I need to choose again. Oh, I remember these 2 being the same. So these highlight up, showing that I've won, and you can see the score increasing over here. And in this memory scramble game, I was very lazy, so I only have two types of cards. So you're going to see a whole lot of unicorns and rainbows, and I chose the right ones, so my score increases. I see a rainbow again. I don't really know where another rainbow is, and so on. I will continue playing, and once I match the same cards, when I click on a new pair of cards, it will go away and turn the screens white so that I can't really click on it anymore. All right, so this is once again a little different from the applications that I've shown you so far. And what we're going to look at right here is this make move function. It's basically the function that we would use whenever a player tries to click on something and make a move of choosing a card. So does anyone recognize what are similar or different about this body of code from the JavaScript and Python code that we saw before? Anything is fine, literally the tiniest details.
All complex.
Sorry?
It gets harder, complex than the previous one.
Yeah, that's true. You see all of these different, things you use to set variables for as well, right? So you see if and else statements. You also see for loops. Those sort of syntaxes are all the same, but Java is what I call a very needy language. So what I mean by that is I can't just say, hey, I want to create a variable positions to clear to equal whatever this other line. I have to tell it, hey, I want to create a variable positions to clear, and it's going to just be a list of integers. Or, hey, I want to create a variable position 1, and it's only going to be an integer, and it's going to be final. So we're never going to change this position 1 again. So what that means is if I say that it's an integer, but I say, nope, I'm just going to give it a string, Java will yell at me and be like, hey, you're doing something wrong. You have a type mismatch because string is not an integer. So in that way, Java is a little different in how we write our code. So it will make us sort of be more specific. And this is nice in the sense that you make less mistakes. You're less prone to writing bugs, because it has all of these preliminary checks per se of explaining and writing out the code. But also, I think honestly, when you're writing the code, it also makes it a little annoying. So you have both things. But yeah, in that sense, other than that though, and I guess it becomes a little more complex because there's a little bit more lines of code. But overall, you see sort of the same concepts being used again. And what's really important is sort of the logic that you think about behind. So it's not really the programming language that's difficult. It's more now on your problem solving, how you want the computer to solve the problem at hand. But enough with all of the sort of fun parts of creating games and drawing things out. Programming can also be used for, solving real-life problems, which I'm pretty sure you're very curious to hear about. So in order to do that, I'm going to be using Mathematica. And Mathematica is very useful for if you want to do some sort of image analysis and see images or graphs in action as you plot them out. So with that, I'm going to be sort of talking to you guys about image segmentation. Given an image, a major problem is that computers aren't that great at recognizing an object of interest from the background. So for us, we can separate the crab from the gray background pretty easily, right? It's pretty easy to see what's what. But for the computer, what the computer sees is just a bunch of pixels that are practically indistinguishable from each other. So what we can do is basically give some guidelines for the computer to work off of, and that's what we do in the middle image. So with the red outline, we say, hey, this is going to be the background. This is basically what the background is. Here's a reference for it. And in green, we say, hey, here's a sort of rough outline of the image of interest that we're looking at. Afterwards, we can use programming to get the computer to figure out what parts constitute the crab and what parts don't constitute the crab. And this is sort of the result at the end, where in white is sort of the areas that the computer thinks is the image of a crab, and the black, which the computer thinks is not the crab. And I would say if you just look at this image, it looks pretty much like a crab. Let's see how we can do this in action. All right, so what we first do is say, this is going to be the image. I give you the image of the crab. I give you the sort of foreground label image, and I give you the background image. Then this is just for you guys to see, just for us to sort of overlay the images on top of each other. And you see here this like image compose or a set alpha channel, which seem like very different sort of functions from what we knew before. But it's sort of just like the sort of turtle package we saw, where it has like turtle.forward or turtle.right. This is yet again another package that we use, that we can use to sort of compose and put overlay images on top of each other. Oops, I have a question. Are Java, HTML, and Python only for programming websites? I should note that HTML is only used for programming web applications, but Python and Java are used for different types as well. So it can be used for developing apps, though Java and Python are typically used sort of in the backend. So basically in analyzing the data that you would use, that you would publish onto the website. So HTML and CSS and JavaScript for sort of what exactly goes on the website, and Java and Python for what goes behind the scenes, in a sense. And Mathematica, I don't think is used for programming websites. I think it's more for analysis tools. All right, so moving on. This is yet again another image. This is just showing it in black and white, which is basically what the computer is going to think. The computer thinks, okay, well, the gray part, the whole image is just a bunch of pixels right now. And I know for sure that the black parts are background, and I know for sure that the white parts are the crab. And what I want the computer to do after is figure out completely change the gray to white and black to figure out which parts are crab and which parts are not crab. This is just me setting the different dimensions. You see another for loop here, and what this for loop does is, all right, change the sort of strength of how much I think that each pixel is background or crab. Then this is me setting a bunch of other samples, and this is the total body of code. You see, once again, I have a bunch of for loops. This is basically going, these for loops are iterating over each of the pixels in this picture. And I have a while loop, which is a sort of new concept. but it's very intuitive if you think about it in the sense that while this statement is true, I want you to continue running this analysis over and over again. If this statement is not true anymore, then I want you to leave and stop running the program. All right, so if I run this program, this is why I think Mathematica is really powerful, because it lets us dynamically, as we're running the program, see how the program is doing. So you see here that, we started out with a very bare bones sort of black line and white line. And now as we're going through, as the computer is going through and trying to figure out what is crab and what is not crab, you see the sort of whiteness being filled in, and the black parts, sort of the outer area, is also being filled in with black. And this is just to show you like how good the computer is doing. So if I overlaid the image on top of the actual crab image, and you can see that the white area is what the crab is, and the sort of black area or the darker gray area is what it's thinking is the background, which is doing pretty well. So in that sense, this is one of the simpler applications, I would say, for image segmentation. A lot of image segmentation tools now also utilize machine learning. And basically what machine learning basically does is it takes in a bunch of data. So it would take in a bunch of pictures that it knows that we tell the computer for sure this is crab, or like for sure this is background, or for sure this is not crab. And then we can run the program again, and with the sort of data that it already has of classifying what is crab and what's not crab, it can also perform better in sort of making the outline a little bit clearer. And of course you might be thinking, hey, segmenting a crab is not too useful, though I guess it's pretty cool to see this image, right? And another application for this image segmentation is in the use of the medical area. So oftentimes, if you especially look at these brain tumor images, you'll see that it's very black and white, grayscale, and it takes a lot of time for radiologists to actually go through the image one by one and outline where the tumor area is, because you have to go pixel by pixel, and you have to manually draw out the outline for each image. But using image segmentation, what we can do is draw a very rough outline around what is not tumor, draw a very rough outline over what is tumor, and get the computer to sort of figure out what the tumor boundary should be. And what this lets us do is figure out the sort of tumor volumes a lot faster, and in some ways more accurately than if a human was to go through these like thousands of images and manually mark them through themselves. So I guess in that way, programming can be, I've shown you some applications for which programming can be used in the real world sort of application. Personally, I'm also still learning and exploring the sort of different aspects of programming. What I think is really great, however, is that with all the advancements, you have so many resources that you can utilize when programming. Like, for example, if you run into an error, search the error up, and I'm pretty sure someone else has most likely had the same error and another person has a solution for it. If you want to learn Python or some other programming language, search up the program, search up like how to program in Python, and there's so many free videos that you can watch, also just books that you can read to learn the language on your own as well. So hopefully in hearing about the sort of different application and seeing the sort of commonalities between the simple and even the more complex programs, you'll also be encouraged to explore, I guess, the sort of limitless opportunities that programming can bring for you. Just remember that programming is really simply writing out just a set of instructions. What's important is finding a problem that you're interested in and want the computer to solve. And it's really important that you just spend the time to create the logic behind how the computer should go about problem solving. And with that, I think just go explore, experiment, and execute with your own programs. Thank you. And if anyone has questions, I would love to answer it. Would you consider JavaScript to be unstable? So I think personally, I'm not like too big a fan of JavaScript. If you're looking into going into developing sort of websites and web applications, I think JavaScript is still very widely used and very favored among a lot of people. So I would say it's stable, but definitely when I'm programming, it has a lot of wiggle room per se when you program. So it's easier to program, but you also get a little suspicious about how the computer is understanding all of these sort of weird things that you're saying. But I would say JavaScript definitely, if you're looking for like going into developing web applications, is a very important tool. What language was easiest to learn for me? I would definitely say start with Python. I think Java or C++ can be a little difficult and intimidating at the start, especially because there's so many like different rules and specific syntax that you have to follow that Python really doesn't. So, as I mentioned, in Java, you have to have a list of one type of thing. So you can't have a list of integers and strings. You have to just have a list of integers. But in Python, on the other hand, you can have a list full of anything from integers to double, so like decimals, to strings, to another list. So with that freedom, I think definitely Python was the easiest to learn. How did I get into MIT? I think is a question for a different webinar. But I would say definitely just follow. I did what I was very passionate about, which was programming. Where do you find the programming websites? I think, so here, let me just go and type in how to program in Python. If I search this, there's so many sites that come up: Code Academy, Python for Beginners. I think there's all these other code school, code for free, YouTube. There's a free YouTube channel where you can learn it's like a crash course, 5 hours on different languages. So I think that's also a very good websites to go check out. But yeah, honestly, I think you can just also check out like the what is it? You can also use Project Boiler. Yep. This, I would say, is not for programming, like learning how to program, but if you want to use programming and like you're not too sure of what problems to solve, there's so many problems here that you can just tackle, and I think these are geared for like math or physics problems, but it also needs programming to use. So I think this is also a really good resource. What books do you recommend for further understanding? I would say, what would I say? Honestly, I don't think I really read a lot of books, but I can definitely look into and give you guys suggestions from what my friends have done and send to you guys through Patrick or through Youngjun or other of the staff members. you prefer front-end or back-end development? I would say I prefer back-end development. It's personally because I'm not so interested in how a website looks or what elements are inside a website, as opposed to, you know, when I mentioned to you guys the example at the beginning where, you know, people are using computer science to analyze and figure out where to even like put items in a store. That's sort of the parts that I'm interested in. How can I use the sort of computer science tools to analyze the data better? How can I use it to make automation a little bit faster in that sense? So I think backend is, I like backend more, but definitely it's just a personal preference for everyone, I think. Yeah, solo run, I guess. I think like Khan Academy also has some, but personally, I think I just went to YouTube channels and searched for Python videos. So what field do I specialize in? I am specifically in computer science and engineering and math, with a concentration in artificial intelligence. So, yep. Do you think it's more useful to study one language deeply or multiple languages? I think it definitely depends. I would say having a deep understanding of one language is very important. But the reason why I used a lot of different languages is because, you know, in my internship right now, I'm working on sort of the website and sort of the front end web application areas. So I learned how to use JavaScript, HTML, CSS that way. In another programming class that I took, it was all about sort of software engineering with Java. So I had to learn Java and then had to do a lot of projects in it. So I think the field is very versatile. I think, don't like confine yourself to, oh, you know, I'm just going to learn Python and stick with Python my entire time. You know, different languages are useful for different types of things. So I think just remain flexible. But when you're starting out, don't think about, I want to learn all the languages. Think about, I want to first learn one language.